about what a conditional statement was. We talked about this notation, if P, then Q, or we can say it as P implies Q. P is our hypothesis, Q is our conclusion, okay? So whatever comes after the if is the hypothesis, whatever comes after the then is the conclusion. Okay, so we talked through that yesterday. Okay, maybe there isn't an if then, but vertical angles share a vertex. We can read that as if we have vertical angles, then they share a vertex, and we can identify the hypothesis and the conclusion. Okay. We also talked about how if we're going to determine whether a conditional statement is true or false, if it's false, we have to give a counter example. So we ended yesterday with this example. If a number is divisible by 5, then it is odd. Okay? Well, here this number is divisible by 5. But it's not odd, okay? Okay, now we're gonna get really thick in the weeds here, okay? So on page 36, right in the middle, we have what's called the negation of a statement, which basically means the opposite. And the symbol is this squiggly in front of the P, okay? And we're going to say not P, okay? For example, if P is the sky is blue, if our statement, not our condition, just our statement is the sky is blue, then if we negate that statement, not P, how would we negate that statement?
The sky is not blue.
Okay, the sky is not blue. We basically just say the no version. Nope. We keep the wording as close to the same as possible. It's just not. Okay? Okay. Now, here comes the fun part, and this is what we get to practice for the next couple days. There are 4 different statements you need to be able to write. First is the conditional statement. If P, then Q. P implies Q. Okay. Then we have what's called the converse. The converse means we're just going to flip the order. Q implies P. Okay. So let's do this. I'm going to write right here. Okay, right here where it says conditional statement, I'm going to write a sentence. If the measure of angle A is 15 degrees, then angle A is acute. Okay, and what I want you to think about is which one is the hypothesis and which one is the conclusion. Which one is the hypothesis? Which one's the hypothesis, Micah? Yep. This is the hypothesis because it comes after the if. This is the conclusion. Okay. Okay, so if P, then Q. So now if I'm going to write the converse, I'm going to take our original statement. This guy right here. And I want to write it as if Q, then P. So all we're doing is we're taking that and we're just switching the order of the hypothesis and the conclusion. So we are going to write if angle A is acute, then the measure of angle A is 15 degrees. Q and P switch places. Okay. Is that a true statement?
I mean, how do you know?
Okay, give me a counterexample.
I forgot what I was going to say.
Okay, Aaron?
16 degrees.
16 degrees. It can be acute and not be 15 degrees. Okay? It can be, but it's not true all the time. Okay? All right. Next, we have what's called the inverse. The inverse, we're taking the original order of P then Q, but it's the negation of P implies the negation of Q. Not P implies not Q. You see that notation right there? Not P implies not Q. Okay. So what would that look like? Not P, I just take this statement and I make it not. So instead of equal, it's not equal. Then the measure of angle A is not acute. I put the opposite for both P and Q. If measure of angle A is not 15 degrees, then the measure of angle A is not acute. Oh, I guess I don't need an M there. Okay, and we're always going back to our original conditional statement. Okay. All right, last, we have the contrapositive. The contrapositive is taking not Q implies not P. So we're taking our original conditional statement and we're doing two things. We're switching the order and we're negating them. So not or no. Okay. In this case, that would look like, okay, I'm going to switch the order and negate them.
I have a question.
Okay.
Did I leave my AirPods out there?
Out there?
Out there.
Out there? I have not been out there to check.
I checked.
You can go check. Okay. So if angle A is not acute, then the measure of angle A is not 15 degrees. Okay, I want you to decide of those four statements, which ones are true and which ones are false. Define them.
It has to be true all the time. This one is, first one's true.
After flex, we went to 6 hours.
For converse.
It's not true.
So like, if we're like kinda.
So if you can give me an example that makes it not true, then it's false. Okay? All right, even if there's just one time that you can pick out where it's not going to be true, then you have to say false. So tell me, is our conditional statement true or false?
True.
Okay, it's true. What about our converse?
False.
Okay, false. We talked about that one. We could say 16 degrees. What about the inverse? False. Same thing. I could give you a counter example of 16 degrees. But what about the contrapositive? True. Okay. Fun fact. If the conditional statement is true, your contrapositive should be true. Similarly, the converse and inverse should give you like both false or both true. Okay? They kind of pair together that way. All right? Okay. So we're going to go to page 2. Leave your journals open, but I want you to go to page 2 for an example that we're going to practice. Okay? Okay. All birds have feathers. Do you see an if then?
If birds, then feathers.
Birds. Okay. So let's everybody write the conditional statement. If it is a bird, then it has feathers. True or false? What bird doesn't have feathers?
Ostrich.
Penguin?
Penguins don't.
Yeah, they do. They have fur.
Yeah, that's good.
Feathers and fur.
Okay, you know what? I don't really want to argue about it. So we're not going to worry about the truth value. So the conditional, I want you to write the converse, the inverse, and the contrapositive. I'm totally cool with you joining forces at your table, either elbow partner or whole table. Penguins have feathers?
So have fancy feathers, like a peacock's feathers, and then
Yes, but those are still feathers.
Apparently Nolan's on it. Okay. Okay, you are writing me. Those 3 statements. We wrote the conditional together.
I'm gonna say penguins have feathers.
so they have 100 feathers.
Converse would be if it has feathers and it's not.
Says a fidget. That's fun.
Shakespeare tales would be if it doesn't have feathers. Well,
Cole, what did you write for your converse?
If it has feathers, then it's a bird.
Do you agree?
Yeah.
Okay, we just changed the order. Good. Austin, what about for the inverse?
If it's not a bird, then it doesn't have, like,
If it is not a bird,
then it doesn't have feathers.
then it does not have feathers. Okay, do you agree with Austin?
Yes.
Okay. Not P implies not Q. Okay. Jack, what about the contrapositive?
If it is not. This one?
The last one.
Yeah. If it has no feathers,
if it does not have feathers, then it is not a bird. Okay, Jack said if it has no feathers, and I wrote if it does not have feathers. Is either one of them like more right or more wrong? Like, it's okay if you say no and I have not, okay? Potato, potato will be good, okay? Oh, Ian. Okay, so, yes.
Then for the Converse,
Mm-hmm.
if it has feathers, then it is a bird. So what if I just grabbed 2 feathers? I mean, I have feathers.
Are you a bird? Yes. You are a bird.
So, if it is born with feathers, how's that?
Like you're saying you could take feathers off
What
a
if I
bird,
was
so be a
born
bird.
with feathers in my hand?
That would be a little bit crazy, Alex Olson. Okay, the last thing we're going to talk about, and I'll get you started on your homework. Okay. Is something called the biconditional statement. Okay. If the conditional and its converse are both true. So that means that P implies Q and Q implies P. That means the statement is true forwards and backwards. If that happens, we can write a biconditional statement, meaning P if and only if Q. So instead of if then, we can write P and Q with an if and only if in the middle. Okay.
Oh, I get it now. I have
Okay. So do you have a question, Alex?
it's just that I thought of something that might be, that might, I think it would make a good activity too.
Okay. Hold on to that. We'll go through an example, and then you can tell us if it works. Okay? So, here on page 2 of your packet, I have a statement. A segment bisector cuts a segment in half. Okay? So, the instructions say write the conditional form and the converse. If both of them are true, then we can write the biconditional. So, what would our conditional statement be? If,
It's a segment bisector.
okay, if it is a segment bisector, then it cuts a segment in half. Okay, true or false?
True.
Okay. That's a true statement. So now the trick is, let's write the converse and decide if it is true. So our converse, if it cuts a segment in half, then it is a segment bisector. If it cuts a segment in half, then it is a segment bisector. Sorry, I get really excited about today's schedule, and it's like, anyway. Okay. Is that true or false?
True.
Alex says true. You agree with Alex? Ollie? Natalie? Okay. So, if both the conditional and the converse are true, we can write P if and only if Q. So in pink, our biconditional. It is a segment bisector if and only if it cuts a segment in half. We can read that sentence forwards and backwards, and it is true. P, if and only if Q. It is a segment bisector if only if it cuts a segment in half. P implies Q and Q implies P. All right, this last example is one of my favorites. Rectangles have 4 sides. Okay, so our conditional statement. If it is a rectangle, then it has 4 sides. Yeah, so is this true? Yeah. True. Hang with us here. We're almost done. Okay. Now let's talk about the converse. If we reverse that, if it has 4 sides, then it is a rectangle. Somebody whispered false. What's your counterexample?
A square is a rectangle.
Diamond. Gosh, diddly darn it.
One of those weird looking shapes where it has 3 straight lines and then that one slip.
All lines are straight.
Well, yeah, straight, but it's like, it basically has
Wait,
two
what about like
sets of
a random
dots,
quadrilateral that's like
longer. It's like a
A
triangle with an
trapezoid?
extra.
That is a trapezoid.
This is a trapezoid.
No, trapezoid. That's a trapezoid.
Okay, cool.
We could say
Trapezoid is a rectangle.
voice is off.
Trapezoid has 4 sides.
Voice is off. A trapezoid, a diamond, a rhombus. Those would all be great counter examples. Since the converse is false, we cannot write a biconditional statement. The definition of a rectangle is a parallelogram with 4 90-degree angles.
Yeah, what's a parallelogram?
Two pairs of parallel opposite sides.
2 pairs?
2 pairs. Parallel, 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 parallel.
I don't trust them.
Okay. On page 3 of your packet, it looks like a copy from a textbook, yes? You are going to do numbers 3, 4, 7 through 16, 18 to 22, but just the evens.
Wait, what?
26 to 28. Look, it's written up on the board, on the sideboard, on the front board. If you don't have enough room, you can use a separate sheet of paper if you need to. Sure. Or you can like circle the problems in your notebook.
I could do that.
Yeah.
Wait, so we're going to 27.
So the only ones that you're doing